Today's problem is drawn from the International Mathematical Olympiads. Specifically, we want to figure out with real values x and to satisfy the following inequality. We always start for this kind of problems to assess, to understand, to evaluate the conditions of existence. In this case, what do we see? Well, we have a denominator and we have a square, and we have a square root in here. So specifically, there are two conditions to be satisfying. One not equal to the square root of 1 plus 2x. This what implies that x must be not equal to 0, okay? The second condition is that 1 plus 2x must be larger or equal to 0. Specifically, we write this condition as this: 1 plus 2x larger or equal than 0. This implies what? That x be larger or equal to minus 1/2. Again, we visualize this situation as follows. Again, minus infinite plus infinite minus 1/2. We'll consider all those values except for this value. So let's dive into the algebraic manipulations to see how at times it's better to stop 1 second and analyze what's going on. So specifically, I would like to get rid of squares. We will do this, and from this situation, from this inequality, we'll step into this. 2x over this x over 1 minus square root 1 plus 2x minus less than 2x plus 9. Is this correct or not? Well, it turns out that this is actually wrong, and to understand why, we introduce the modules specifically, and we talk now in general. Specifically, if so, what could we infer from this? Well, we infer that the modulus of x, it is equal to what? Square root of x squared. And this is very important. So this is basically a way of ascertaining that x be non-negative. Therefore, this guy in here must account for the modulus. Specifically, this is not the correct form. We will consider rather this modulus of x over modulus of 1 minus square root of 1 plus 2x must be less than square root of 2x plus 9. If we apply the modulus definition, then we can write that if x is larger or equal to 0, then what follows? It follows by definition that 2x exactly is less than square root of 2x plus 9, 1 minus 1 plus 2x. Basically, the denominator multiplies the right-hand side of this inequality. And likewise, as we did earlier, x less than 0, And this implies that minus this time 2x be less than square root of 2x plus 9 multiplied again. In this case, it's different, so we have minus 1 plus square root of 1 plus 2x. So let's solve for the former. I'm going to multiply this factor by this term and then this term. So we have that 2x is less square root of 2x plus 9, and then in this case we have minus and then again square root, and then we just multiply this. This involves 2x plus 4x squared plus 9 plus 18x. Now I pick up this guy in here and I move it to the left hand side of the inequality, and we get to this situation. So we have square root of 4x squared plus 20x plus 9 less than square root of 2x plus 9 minus 2x. Now, if we square both sides, what we obtain? Well, it's easy. It's 4x squared plus 20x plus 9 less than 2x plus 9 plus 4 squared, so 4x squared minus 4x square root of 2x plus 9. So in here we have basically, as you can see, few terms that cancel out. Specifically, we have this 4 squared, then we have this 9, this here, and this overall we have this, so we have 18x plus 4x square root of 2x plus 9, this less than 0. Attention, because this is crucial, this is quite interesting. Now, it is interesting because we can factor. Remember, as I've explained in the previous video, you have to try to factor when you have the possibility. In this case, we can factor, and we can factor it as follows. As you can see, here we have two factors. One factor, and then we have the other factor. However, as you can see, we are considering the first condition, and the first condition involves imposing this condition. It means that in this case, this is for sure positive. So in order for this inequality to be less than 0, we just require that this guy in here is negative. So we basically require what? We require that 18 plus 4 square root 2x plus 9 be less than 0. X finally must be less than what? 45/8. Please, you always have to carry over the initial conditions, so we can specify the situation, we can depict the situation through visualization. Specifically, let's depict the situation by accounting for this fact here and the initial condition that we have expressed in this picture here. We said that must be x less than this value, so we are in this situation, but we are considering only this situation. It means for those values. So again, have we finished? The answer is of course no. Why? Because we have to work out the second equation. The second equation is this one, which actually entails performing the same kind of manipulation but for negative values of x. So basically it turns out that the solution is that the inequality is satisfied basically also for this value. If you just repeat exactly what I have done thus far, then it turns out that the solution, it is x must be an element of this interval 45/8. We don't repeat the same manipulations because basically it's just a copy of what we have done so far. And this, it's x not equal to 0. So this is actually a terrible proof because it's too lengthy. I have implemented though to talk about modulus. As you can see, modulus is a concept that lends itself to a lot of ambiguity. So I have exploited this situation, this lengthy proof, to introduce the concept of modulus and to talk about it. Of course, you have to try to optimize the process of problem solving, and in this case the proof of course is too lengthy. How do we go about to expedite our solution? Well, we can apply what I personally call it change parameters principle. Why this change parameters principle? The square root, as in general is the case, it is a kind of disturbing event. Is disturbing because this is a nonlinear term. Moreover, please note also this minus, and when there is a minus and there are two terms in this case, well, this reveals a pattern. It basically reveals the difference of squares idea. So let's multiply basically both left and right hand side denominators by this guy 1 plus square root 1 plus 2x squared in this case. Can you see the pattern? Again, when there is a minus and there are two terms, remember there is to apply the difference of squares. 4x squared over, when we apply that guy, 1 minus what? Well, this cancels out, and what we obtain? We obtain minus 1 and minus 2x. So overall we have 1 minus 2x, and of course square, and then we have the same 2x plus 9, and we write in here the guy that we used to multiply the first denominator. We have 1 plus 2x all squared. So this implies, what does it imply? 4x squared, then minus 2x squared, and here there is a moment of satisfaction, you know, less than 2x plus 9, and then again 1 plus 2x so this is 1, as you can see. Please, we move this denominator in here, and we have 1 plus square root of what? 1 plus 2x square less 2x plus 9. So we have to impose that this guy here be a linear term. No, we can call it, we want square root by 1 plus 2x, and we call it p, for instance. We call it p, okay? Again, is a change of parameters principle. We change the parameters. This is no longer linear, stops being linear, nonlinear, and we have another term that is a linear term. So in this case, this is what we have. It turns into what? It turns into 1 plus, well, p squared less than 2x plus 9. This implies that if we square 1 plus 2x, obvious p squared. And here, this leads to 2x equal p squared minus 1. Okay, so we plug this into this inequality, and we have what? This implies what? 1 plus 2x, again, be less than 7/2. Half except for 0. So this is not considered, and then we have 45/8 again. This is consistent with the result that we have found using the sloppy solution. So again, the inequality is solved for the following range of value. Minus 1/2 plus 45/8. Not included, okay? X not equal to 0.